நீங்கள் பேசுறது
அப்படியா சரி அப்படியே வழி வச்சுதா உடனே போகலாம் போகலாம் கெஸ்ட்
Education is not learning of facts, but training of the mind to think. So do something more creative, interesting and productive too, so that we all are here to make it a great day with good memories. A very warm good morning to one and all present here for the glorious opening of International Conference on Energy, Smart Structure and Manufacturing. It gives me immense pleasure in welcoming the galaxy of intellectuals, honorable guests, respected teachers and beloved students to the IECSSM-2022. Students, hold on to your hearts because you may eventually discover the beauty of this beautiful day. And now I request you all to rise for the invocation song.
Vandeham Sharadam Visharadam Jnanadam Varadam Vandeham Sharadam Visharadam Jnanadam Varadam Vandeham Sharadam Visharadam Jnanadam Varadam Vandeham Sharadam Sukha Swachha Swarupini Swachha Hridaya Nivasini Sukha Swachha Swarupini Swachha Hridaya Nivasini Swaprakasha Rupini Swaprakasha Rupini Swaprakasha Rupini Vandeham Sharadam Visharadam Jnanadam Varadam Vandeham Sharadam Visharadam Jnanadam Varadam Vandeham Sharadam.
Thank you all. Have your seats. And now, I requesting the advisor of Rajalakshmi Engineering College, Dr. C.R. Muthukrishnan, to present the bouquet to the chief guest, Dr. Professor Jnanamurthy. Now, requesting the principal of Rajalakshmi Engineering College to present the bouquet to the chief guest of honor of the day, Dr. Mani S. Manivasagam. And now, I requesting Dr. S.P. Srinivasan, the Director of Mechanical Sciences of Rajalakshmi Engineering College, to deliver the welcome address for the International Conference on Energy, Smart Structure and Manufacturing 2022.
Checking. My humble salutations to everyone present here. And thank you for joining us at the second International Conference on Energy, Smart Structure and Manufacturing. It's my pleasure to walk you through the conference, introduce you to the speakers and delegates who have come in person and going to participate online today to share their knowledge and enhance our mental horizon. Today's conference has about 450 participants participating from India and abroad. making this conference a truly international conference in spirit. Our institute was started in 1997, almost 25 years back, in a time where the internet was just a luxury for many people, and the conference was only the way people could enhance their knowledge and share a difference of opinion on a common platform. So this conference has come a long way and has surpassed the various challenges that our education system has faced over the years and has adapted to the changing technological trends in the industry. We are proud to announce that today that the chief guest of this conference is Professor Dr. R. Jnanamurthy, Institute Chair Professor Mechanical Engineering, IIT Madras. Our guest of honor, Dr. S. Manivasagam, Head Technology and Services, 3D Engineering Automation, Pune. Thanks for our invitation, sir, for inaugurating this session. Thank you, sir. A warm welcome to our beloved advisor, principal, deans, directors, and my dear colleagues. It's my pleasure to welcome all the speakers and participants today for the two-day conference. This conference holds a special value because this is the first international conference in the campus where the entire conference is taking place on a digital platform. Due to the changing time caused by the COVID-19, many conferences in the future that will be conducted remotely through the use of advanced technologies such as augmented reality and virtual reality. So the major outcome of this conference has always been the betterment of our students. I request all the delegates to participate in all the activities and discussions through the keynote speeches, offline and digital platforms for the next 2 days. Thank you very much.
Thank you, sir. Requesting Dr. S.N. Murugesan, the Principal of Rajalakshmi Engineering College, to deliver the Presidential Address for the International Conference on Energy, Smart Structure and Manufacturing 2022.
Very respected Chief Guest, Dr. Jnanamurthy, Professor IIT Madras, respected Guest of Honor, Dr. Manivasagam, Head Technology and Services, 3D Engineering Automation, our beloved advisor, heads of various departments, and friends from teaching fraternity, and my dear students. Very good morning to all of you. First of all, I would like to congratulate SPS and team for organizing this event. After 2 long years of struggle, this is the first major event that we are holding, wherein many are attending in person. Thanks for that. It is really bringing in a lot of positive energy. And also I would like to welcome and thank our chief guest for joining us in person, and join SPS in welcoming other keynote speakers who will be addressing through internet. They will be joining you in the remote mode. I urge all the participants, both faculty from REC, from other institutes, students from REC and other institutes, to participate and make sure that all the sessions are interactive in nature. At this juncture, I would like to highlight only 2 points. The first point is the boundary that is separating different disciplines of engineering is vanishing at a faster pace. Though we are introducing several disciplines like mechatronics, robotics and automation, we are introducing new discipline. It doesn't mean that they are going to be learnt and practiced in silos. Definitely, the boundary that is separating different disciplines is vanishing. Many new opportunities are emerging in the intersection between different specializations. As faculty, we all have to evince interest in students. As a student, you should also realize that it is not enough if you learn the concepts and be master in your own discipline. You should try and use opportunities to learn matters that are relevant to allied fields in a structured way. There are several options we are offering you through this CBCS scheme. Be it your open elective or online courses, make use of the opportunity to see that you are also learning adequately in the allied fields. For example, a mechanical engineering student should not think that I am not related to IoT, I am not related to programming. All these things are integral part. If you talk to anybody in the company, every company is now attempting to introduce the Industry 4.0, wherein every machine they are connecting to the cloud through IoT, so that the data collected from every machine on everyday basis could be useful for predictive as well as breakdown maintenance. So if you want to get employed in a core company, definitely company will look for at least some basic knowledge in IoT and programming. So you have to understand that not only a sound knowledge in core, but also certain level of exposure and knowledge in the allied field is very important. The second point is, I hope many of you would have studied thermodynamics. Any analysis is incomplete if we just apply first law of thermodynamics. We have to apply second law of thermodynamics. Why I am insisting is, take one example. The electrical vehicle is introduced and it is given a lot of emphasis. What is the logic behind giving so much importance for electric vehicle? Can anybody tell? One of you, please. Environment. Why we should bother about environment? At the end of the day, it is for the society. If we do not restrict the emission of greenhouse gases, which in turn holds the large amount of heat and leads to global warming. This global warming in turn causes a lot of environmental issue. So the underlying reason for this push is electric vehicle. Push given to electric vehicle is societal need. And do you know one of the most serious issues that has already evolved? Now it is in the nascent stage. Use of electric vehicle, it is at the nascent stage. Even at this stage, it has triggered a very serious societal issue. That is, I hope all of you are aware that cobalt is one of the metal needed for making battery. 70% of the cobalt is taken from one particular country in Africa, and that 70% of the cobalt primarily comes from illegal market. That illegal market is employing majority of children under the age of 15. And the death that used to be in hundreds has become thousands now. And it is projected that if we reach the target of 60 million electrical vehicle annually, then the death, children dying while exploring this illegal cobalt will be in lakhs. This has already triggered a serious societal issue. While trying to solve one societal issue, we end up with another societal issue. Why I am mentioning is, now the urge or need is to find another substitute for cobalt. So whenever we want to innovate, we have to have a clear view, a complete view of what is going to happen. We cannot depend on one particular raw material when we invent something. We should always explore for different substitutes And also we should ensure that the availability of any particular raw material for such a large use should not cause another problem. So plenty of opportunity is available for mechanical engineers. So you all have to focus on your studies and make use of this platform. This may be a good beginning for you to explore and get settled in a job of your dreams. With these words, I once again congratulate the team and welcome all the participants. Thank you very much.
Thank you so much, sir. Requesting Dr. C.R. Muthukrishnan, the advisor of Rajalakshmi Engineering College, to deliver the inaugural speech for ICESSM 2022.
Good morning, and it's really delightful to see the hall full and on a bright sunny morning. Institute Chair Professor, Mechanical Engineering from IIT Madras, and also Founder Director of IIIT DM, the Indian Institute of Information Technology, Design and Manufacture. Many IIITs have been created in the country by our governments, but this IIIT DM is unique in the sense, even though it has information technology, it also has design and manufacture added to its, describing its focus and activity. Special welcome to you, sir. And I also welcome Dr. Mani S. Manivasagam, Board Member, Head of Technology and Services, 3D Engineering Automation from Pune, who has vast experience and who is in a very unique kind of, making unique contribution in engineering. And this conference is a very interesting theme. Of course, at Rajalakshmi Engineering College, we have run several earlier conferences. In 2013, we ran an international conference on surface engineering for research and industrial applications. In 2018, we ran an international conference on green manufacturing, analysis, automation, process, products, and energy. And then this in 2022. In between, we've also been running national conferences. This particular international conference, as I mentioned, has a very unique theme, interesting theme, which goes as energy, smart structure, and manufacturing. I think the synergy and connection between these, with what is captured by these words in engineering, in the broad field of engineering, is very interesting. Energy is what makes life. The flow and consumption of energy is what makes life move forward, and what makes the world interesting, and what makes the world progress. Because there are various forms of energy, heat, light, sound, and so on. And mechanical engineering is being mainly concerned with harnessing energy, transforming energy from one type of source to more usable forms and so on, be it products like refrigeration, air conditioning, cold storage, heaters, what have you. Then we have smart structure. Structure indicates the notion of a system, something that's made up of many parts which work together as a team, which are interconnected, and so on. And we are putting the adjective smart to it. Smart means that we want to lend some intelligence and some additional capability to these structures and systems to serve whatever purpose it's needed. Of course, the smartness can come in a variety of ways. It can come in terms of efficiency, efficient use of energy. It can come in terms of matching the functionality requirement. It can come in terms of being user-friendly, being connected to the users who operate and who derive services out of these structures and systems and so on. And of course, manufacturing, we can extend it to include design of products and then producing these products using various kinds of materials and so on, also delivering and also post delivery of these products to the respective community or users in terms of service and operation and maintenance and so on. So this is a very interesting title which captures a whole gamut of activities that touch upon engineering. And it's also very interesting to note that this conference is organized by the Rajalakshmi Engineering College by having several departments come together, the Department of Mechanical Engineering, Mechatronics, Automobile Engineering, Aeronautical Engineering, Robotics and Automation, and Civil Engineering. So we can see that the smart structure and energy and the manufacturing or production and manufacturing, including the aspects of design preceding manufacturing and aspects of service and maintenance through operation and life cycle subsequent to manufacturing. All these aspects touch upon these different disciplines. We call them core disciplines, and they constitute the fields of engineering which have a very long standing of going into more than a couple of centuries, and they have seen enormous progress. If we see the progress in our society over the last few hundred years, we can attribute a substantial amount of this as arising out of the contributions coming from these fields. However, in the last 70 years or so, 60, 70 years post-Second War, we are seeing an inflection in terms of how these fields have been changing. But one thing we realized that if we scale up the way we were doing things, we would end up with more serious problems than those that we are addressing and solving. This is touched upon by a principal in his presidential address for the conference, where the problem of problems impacting society, sustainability, recyclability, waste management, environment degradation, and so on come into play. So we need to make a departure in terms of what we were doing to address the future. And this is broadly captured both in the space of education, technical education and general education, and also in terms of practice in the field by a variety of new technologies which are beginning to impact all these different fields in significant ways. The new technologies broadly go under the title of information technology. Basically, they try to make use of information. Information is produced from data. By looking at data during the operation and trying to make systems smarter and also factor them into the design and also the production or manufacturing of these systems. And also, as I said earlier, into the post-manufacturing service and maintenance and service of these systems. There are several examples, and we still have a long way to go. So the future of engineering is much brighter than it has been, and there are more challenges, especially for the young engineers and also the practicing professionals. This has led to a thrust for innovation. In fact, many of us, I've lived through I'm actually a pre-independence born in our country, and I've lived through almost all the post-independence period of India, modern India, and I can say with confidence that the impact that we are seeing in terms of the global awareness that's coming about in terms of how the field of engineering is changing is something that provides us many new opportunities. So how do you make systems smart? How do you make structures smart? Smart can mean applying some kind of intelligence, but intelligence is based on some experience and analysis. There are several dimensions to it, but one of the key dimensions is based on data and analysis of data, learning from that experience that data tells us in order to improve the performance of systems. So this is manifested in many ways already. It's not that it's something very new, but it is gaining prominence now. For example, many of the equipment which are consuming large amounts of energy, you would have noticed in the last something like 20-25 years, they have a mode called standby, wherein they automatically go into a low power consumption, ready to come into action only when required. It could be your TV set at home, it could be a laser printer, it could be even an idling engine, for example, and so on. Okay? So that's one dimension of smartness. That's simply recognizing that the operation of this device or this system is now in a phase where it's in a quieter mode, and that it can spur into action maybe only when the external factors arise to ask for it. That's a very simple example. Now going forward, we can expand it in many ways because of new technologies that are available. There's a statement that data is the new oil, which means that as systems provide service, as they're used and so on, there's a substantial amount of performance detail, operational data that can be collected through sensors and so on. And it's not merely the sensors that pick up the operation of the data, it's also aggregating this data in terms of being able to collect it in some meaningful way and do some analysis of it. The analysis can be simply, it could be based on model when it is more sophisticated, or when it is less sophisticated, it could be based on some kind of a interpolation, extrapolation, prediction kind of approaches to use this data. So that's why they say data is the new oil, and based on this, the operation of many of our devices, many of our systems can be improved substantially. There are many examples that can be given, and this aspect is requiring new competencies on the part of both professionals and also students who want to enter the field of engineering, who are studying to become graduates or qualify themselves and enter the field of engineering. And so what are these technologies? And they're not new. They didn't come out of the blue all of a sudden. They've been there. It's just that they gain more prominence. For example, how do we again, it's not merely gathering data through sensors. Sensors are important sensor technology. It's also important that these sensors, the devices where the data is gathered, also communicates so that it is able to put together this data in an aggregate form and make it more useful and render it fit for use and so on. So this can be stretched to even large examples, and there is this word called digital twin. So if I can mirror a system in terms of models and data, not all models need to be analytical with only strong mathematical foundation that come from fields like originally fields like calculus and many other associated fields. It could also in the form of observations culled into some kind of a usable data that is captured in the form of fit for interpolation and extrapolation. So So these techniques are important to be included in engineering. For example, you take a very simple device like a vacuum cleaner. We used to have vacuum cleaners which had to be lugged around with a long cord and so on, but today you have these gadgets which have no tether. They can go and power themselves from a wall outlet through sensors, and they can move around the floor and vacuum the floor in a matter of maybe something like 45 minutes or 1 hour. You can even clean a whole house of about 1,500 square feet and so on. So these are sensors for obstacles. It can sense obstacles and make sure that the objects are safe, and also the device itself is safe so that it doesn't get damaged and so on. And it can sense its own battery level, and when the charge is low, it can go and connect itself for recharging and so on. And you can set several modes of operation. So, and a device like this, we may call it a very simple robot, but but these devices these are already available. They're available in the market. You can, and many in India are already beginning to use it quite extensively and so on. And another good thing about this is that this automation of a simple task like cleaning a floor or cleaning some surface and so on helps, because you don't have to put the manual work which many in the higher age groups are not able to do by themselves. And also many places like hospitals and so on, other areas which require more frequent cleaning even within a day and so on. So there are several interesting and productive applications for these devices. This can be extended to plants. Even a manufacturing shop, a production shop with suitable instrumentation and a dashboard and so on. We've already seen this in operation, but the dashboard will have a manual person with controls and so on. Now, some degree of automation is possible in that by aggregating this data and seeing how the flow of assemblies, sub-assemblies and material is happening in a shop floor and so on. So these are technologies which are applicable in a variety of different situations, and these have to be integrated into the traditional disciplines of civil, mechanical, and other fields of engineering. So I think there is immense scope for both research, good projects, as well as for modernizing our industry, and also in terms of education. So bringing all this together, I think in that respect, this conference is a excellent initiative, is a great move forward, and of course, the buzzword that's been used is Industry 4.0, but I would say Industry 4.0 to serve society. I think we need to add that small phrase to it, because I think it's not Industry 4.0 for its own sake, but it is with the touch of serving society. And this is where I think we in our country have a much greater opportunity and challenge compared to many other advanced nations. They have already progressed through a certain path, and they have the somewhat enviable and ridiculous task of undoing some of what they have done. We in our country don't have that problem to the same severe extent, though of course if we go on the copy and evolve, copy and proceed mode, we might land up with those problems, particularly in terms of scaling. In fact, it is said that if the energy consumption due to industrial revolution in India had happened at the same pace it happened in Western Europe and America, we would have burnt the globe 6 times over. That's the kind of energy consumption we would have had. So I think looking back, even though the 70 years have not been as illuminating and as satisfying as we would have liked it, But I think there is a saving grace in that because we have a new opportunity looking ahead of us in terms of the possibilities that have been created by these new technologies. One final word about this data as the new oil. We see that the way leveraging data for new types of solutions, smart, intelligent solutions in many applications is using very large amounts of data. In fact, it is mind-boggling. The model that's created has billions of parameters sometimes. These have to be calculated. This is it's a design process, you can say. I'm talking about something what's called a very large neural network of various structures and so on. These are billions of parameters, and these billions of parameters have to be calculated. To calculate these billions of parameters and make them stable for prediction, for further use, be it in recognizing images or recognizing voice or generating something and so on, requires a mind-boggling amount of data. If you have to set a billion parameters, you probably need at least 10 times, if not 100 times that amount of data. Now, that's very hard to come by. But some of these IT companies who have offered free services, they're well known. They have done a good job looking back in retrospective, but they have to change their ways going forward. They have had access inadvertently to a very large amount of consumer data, very large amounts, mind-boggling amount. If you look at the number of transactions that happen per second and the amount of data that gets gathered about behavior, human behavior, consumption, use of gadgets and so on, with the ubiquitous network to which they are connected, there is a large amount of data. But many new problems in engineering cannot be solved with the same thinking. The approach can be the same, but the same thinking won't work. Suppose I want to, let's say, diagnose and analyze failure data from certain equipment, certain gadgets. Am I going to get billions of candidates of data for that? No. You might at best get a few thousands. You may get few tens of thousands of data. So how to use data smartly is a challenge ahead of us. How to make more sense of the available data and how to design what data is to be collected in what manner, I think is a great challenge ahead of us. So even though the field looks as though we have arrived, we are just barely started. I think with those words, I think conferences like this are very essential, and I hope it will open up new vistas for all of us, all the participants and so on. We have an excellent keynote address and followed by a special address from our guest of honor. And I congratulate all the heads of departments, especially mechanical, mechatronics, automobile, aeronautical, robotics and automation, and civil engineering, Professor SPS and his team, and wish the conference great success. I'm very happy to inaugurate the conference. Thank you very much.
Thank you, sir, for sharing your knowledge with us. Requesting Dr. G. Tanigayarasu, the Dean of Mechanical Sciences of Rajalakshmi Engineering College, to address the gathering.
Good morning. I'm honored and very happy to be with you with this occasion. I'm very happy to notice this hall is full only for a few occasions, and this occasion also this hall is very much full. That gives me a great pleasure for having arranged this conference, international conference on energy, smart structure and manufacturing. So when you say that is respected advisor, respected chief guest of the day, or Jnanamurthy sir, and my dear friend S. Manivasagam, board member and head of technology and services, deans, professors, HODs, faculty members, and participants from various organizations or various colleges. I am very happy to give the inaugural address for this function. When you say as energy, during my college days, like you, so the energy that is what you can have is the fossil energy for cars and two-wheelers has to be changed because there is a shortage of fuel. So they thought of going for ethanol car. But ethanol car can run, but side effect, what you can call it as environmental effects, anybody can stand near the car for 15 minutes, you will get a headache because of the output. So that is a reason for failure. Not only that, and you cannot be able to manufacture ethanol without water. The ethanol will contain minimum of 5% of water. If the water is present, what will happen? Piston rings, and everything will corrode. Your life of your four-wheeler or two-wheeler will be very, very minimum. Okay, so that is a failure. And we had another conference at the time, what you can call it as, we were exposed to various types of energies. What are the energies? Geothermal energy, because under the earth we have a lot of heat is there. How to extract that heat and then convert it into an energy? Or tidal energy, and then we can have wind energy, and then solar energy. Like that, the topics are started beginning and then going for research, how to make use of these energies for useful way. And then we can have that is come to smart structure. So now we are in the digital era. All your electronic equipment, your what you can call it as your cell phone or what laptops and other things. In the olden days, about 10 years back, the laptops are giving lot of heat, and they tried to convert that energy into some useful work. So that was the research. But what is the smart structure mean? That is what you can call that. They are made in a board. They are assembled. The components are assembled in the board, and the board will be giving heat. Because of the heat, the board will be deflect. The board deflects. What will the data you are getting will be a wrong data. So how to make this always in a straight is the smart structure. So that you can have, that you can identify because of the heat what is the part to be deflect and how to make it as a further in the normal plane. So that you can have to go for some actuators, and then you can able to keep it. That is again this manufacture of actuator, finding out the deflection and other things are mechanical area. The sensor and other things are what you can call as the areas from electronics as well as computer science. Then we can come for manufacturing. Now it is the order of what you can call as digital manufacturing. That is what you can call as 4.0. 4.5 also has come, but still we are in 4.4 in the educational institution. We are teaching what is a 4.0. So you can see that is what you can call as online measurement. Say if we take for generally everybody has seen there is a lathe. What it is, the carriage is there, it moves. If it moves many times, then what you can have after some time, there is a deflection will be there. So what you can have is, you can go for a non-wearable material, that is a cast iron. That's why you are making as a bed as a cast iron. You cannot go for steel or other type of material, which has what you can call as a high wear resistant material. Similarly, what you can have is, that is what you can call it as manufacturing side. You can have, that is you can go for measure the values, how much is the change, how whether the tool is worn out or there is a component has, that is a system itself is worn out, or you can go for a robotic system so that you can manufacture the component with a high accuracy or what you can call it as with a reasonable tolerance. What you have to do is you have to go for depend upon sensors, and then what you can call it as codings and other things. So we are going for what you can call it as robotic systems. In the case of robots, the engineer should know, that is a mechanical engineer only know that is a movement or what you can call it as velocity and acceleration. You should readily learn, and then only you can able to fix the movement of these robots at a particular position. Then the position should be identified and measured by means of what you can call it as electronics. And then the coding will be done by computer science people. So you have, it is a multidisciplinary area, so you have to go for what you can call it as the order of the day is you cannot learn only for mechanism, then you have to go for study of structures, study of various materials, and study of what you can call it as programming, and then study of what is sensors. This will help you, that this seminar, this is a kind of a seminar will help you to find out your idea, to kindle your idea for the various paper presentation, and then you can able to have a knowledge. From there you can develop whatever this field which you want to develop more, and you can able to concentrate. I hope there are more number of paper presentations are there. Number of paper presentation I am not aware of. That is, we will have, that is for the 2 days we will have about 10 section of paper presentation, and I hope that it will be benefit for all the participants, and then make this seminar as a more successful one. Thank you for the opportunity given.
Thank you so much, sir. Requesting Dr. S.P. Srinivasan, the Director of Mechanical Sciences, to the dais. Sir, to the dais. And now, I would like to call upon the Chief Guest and the Guest of Honor to unwrap the proceedings along with the Dean, Advisor, and the Principal of Rajalakshmi Engineering College. Thank you. Now I call upon Ms. Kavya of 3rd Year Civil Department to introduce the Guest of Honor, Dr. Mani S. Manivasagam, to the audience.
Perfection is not attainable, but if we chase perfection, we can catch excellence. Good morning, everyone. I am delighted to have an opportunity to introduce the guest of honor, Dr. Mani S. Manivasagam, Board Member and Head of Technology and Services, 3D Engineering Automation LLP. We are honored to have you, sir, in our midst. On behalf of our management, we welcome you, sir, and thank you for accepting to grace this conference. He completed his undergraduate in mechanical engineering at University of Madras and accomplished his post-graduation and PhD at Anna University. He has more than 25 years of work experience in the field of mechanical engineering. He has been helping organizations to develop great products in shorter span of time and has given his part in various workspace and also designated as Group Consultant in NIIT Limited. General Manager, Product Engineer, both in Emerson Climate Technologies and Indian Piston Limited. Head of Engineering in Tooltech Global Engineering Private Limited. Executive Vice President at Onward Technologies. Global Head of Vehicle Engineering at Tata Technologies. Moreover, he has played key roles in winning multi-million-dollar deals for global giants, including a luxury car manufacturer and transmission system. It's a pleasure for all of us to have such great personality among us. We are all keen to hear from you, sir, about your journey, knowledge and success motto. Now, I request the guest of honor to share his thought with us. Once again, we welcome you, sir.
PPT PPT PDF சார் கொடுத்தாரு வேணுமா இது வேணுமா
இதை சேவ் பண்ணுறோம்
டிஸ்டர்ப் பண்ணுறாரா பாலிசி பண்ணுறதா இல்லை இது அதான் அந்த பிபிடி வெர்ஷன் ஆமாம். Hello, respected chief guest, advisor, dean, principal, HODs of various departments, other faculty members, and delegates, student delegates and faculty delegates. Very good morning to all of you. Good morning. That's it. I know that many of you have come from long distance and getting up early in the morning, reaching the place venue at 8 o'clock. I was surprised that at 8 o'clock you start functioning. Phenomenal. It's in fact, I am a bit emotional because I am on stage in person after almost 2.5 years. I used to participate in a lot of such conferences and all, particularly in Maharashtra. I am well known in the industry circles and academic circles there. Occasionally in Chennai circle also. But last 2.5 years, it's full of Zooms and team meetings and Google Meets and everything. And as JT sir mentioned, seeing such a huge crowd is making me very, very happy. And yeah, we are all back to normalcy. And thank you for the opportunity for me to be here amongst you and being part of your first international conference after pandemic. Excellent. Thank you very much. So, thank you for a nice introduction. And next up, I believe I have about 20 minutes. I'll take you through some important aspects. How this, the theme of the conference on energy, structures, smart structures and manufacturing is relevant for the industry which I belong. Predominantly it is automotive industry. Right. I represent 3D engineering. Which one is that? Right. Okay. All right. So half of our one portion of our company deals with products like ANSYS and Siemens industry solutions, and other half is providing consulting support to industries, predominantly automotive, auto suppliers and any other industry. We are partners for Siemens as well as ANSYS. Okay, as I mentioned, the theme of the conference is energy, structures and manufacturing, and I should ensure that I speak about this one and the relevance of the seminar topic to my industry. Yes. But since I belong to automotive, then I'll try to look at the importance of these theme topics for the industry which I belong to. But one more area which is still very, very important for my industry is reduce product development time. So I have taken the privilege of including this in this brief talk. And I'll try to speak about where or how academic institutes can collaborate with industries, consulting companies like us or OEMs or tier 1 suppliers. For me, energy is, as principals are mentioned so nicely, energy is green. Green is EV development for people like us. Last few years I have been deeply involved in electric car development, not two-wheeler development, worked for global automotive manufacturers and startups. Structures, for me, it is lightweighting. Why? I'll explain you. Manufacturing, sir mentioned about digital manufacturing. JT sir mentioned about digital manufacturing, industry 4.0 to 4.4 and 5. And reduce product development time. How do we do it? Use CAE. I am one of the first users of CAE, FEA in the country. Later on, we found out that I was the fourth user of FEA in the country. Started with ANSYS in 1988 and 89. JT sir was my teacher. Okay, let us start with energy, green, EV development. What is happening in the industry? We all speak about a lot of buzzwords. Electric vehicles, connected vehicles, autonomous vehicles with different ADAS levels. Level 0, 1, 2, 3 and 4. We are still in India, still in 0 level and occasionally at 1 level, whereas people are talking about 2 level. 2 is still advanced. Let us be clear that reaching ADAS level 2 is still very, very advanced. Then full autonomous is level 5. Driverless is autonomous level 5. And very, very important area, every one of the senior speakers spoke about the electronics, controls, programs, embedded systems and all. Absolutely, these are all programming related. This is the gap what I see in our mechanical. I am a mechanical engineer. This is the biggest gap. Principal sir mentioned about this one. Please concentrate on programming, MATLABs, Simulink, not just ANSYS and all those bigger 3D tools and all. Programming is very, very important. Pythons. Please ensure that you learn this one as a part of your extended academics. Because the gap between electronics and mechanical is slowly reducing. In fact, today's car, mid and high level car, the cost what we pay, 18 lakh car, it's almost 7 lakhs is paid for the electronics and embedded systems, not for the metallic thing which we are typically used to, which I am typically used to. Quick run through of what is happening. The data is for 2020. In 2020, China has produced 12 lakh electric vehicles. USA 3 lakh electric vehicles. Whereas percentage wise you can see, I don't know how many of you can read, but I'll tell you. Norway in 2020, 75% of Norway's electric cars are electric cars. Whereas China, even though they produced about 12 lakh cars in 2020, it is only 6.2%. So imagine what's going to happen. It's going to explode. China is fully into preparing to become full electric car market, car country, electric car country in another 10 years. Huge potential in this area. So, statistics, in 2017, world has produced 1 million electric cars. In 2020, 2.5 million. In just 3 years, it has become 2.5 times. 2030, it is going to be 30 million. Where are we going to stand in India? As per the formula extrapolation, India will have about 7% of the cars, passenger cars, electric cars. But government is trying to accelerate a lot of programs, a lot of support activities from Government of India. The Transport Minister is a fan of advanced energy cars. Last week he was driving in a hydrogen vehicle. He came to Parliament in hydrogen powered vehicle. Many of you might have noticed that one. So the curve what you see is that, half of you may not be able to see that, but I'll read it. Indian potential, the 7% prediction can become 30% or somewhere between 7 to 30%, maybe 15 to 20%. The scenario is what I see in the market. I operate from Pune, very close contacts with automotive industry and all. So reaching a number 20% electric cars in 2030 is not difficult. And certain things are going to be very sure. March month, already 10% of our two-wheelers were two-wheelers sold in India last month were electric two-wheelers. Forget about all these accidents and fire and all, that's a separate story. But number, volume-wise, it's going to grow. It's not going to stop. Exactly a year back, few hundred EV scooters were produced. Within a year, it is almost a lakh. From hundreds to lakh EV vehicles are produced. Lot of investment. Last month, Maruti also announced, there is a laggards, slow movers, 10,000 crores, Maruti alone is going to invest in electric vehicle technology. Everybody is speaking about. Honda last week made an announcement that our city will become EV. Honda city will become EV. So next topic is structures. For me, smart structure is the lightweighting because battery has increased the electric vehicle weight considerably. If you want to have a good range, your battery pack would be anywhere between 400 kgs to 500 kgs. Imagine a Maruti Alto vehicle or Maruti Swift vehicle which is about 1000 to 1200 kgs. If you add 500 kg of battery weight, what will happen? Mind-boggling, right? It's almost 50% of the weight will be added to this one. So it is very, very essential to reduce the weight wherever it is possible. How can we reduce weight? Use light materials, lightweight structures. Could be steel, a different kind of steel. My generation, when we studied, we used to blindly use a number 250 Newton per mm square strength. Today people are using 280, 300 and all. But believe, 1000 Newton per mm square steels are available in the market. China uses it. I happened to be in China, looked at their market and their steels and all. China has got such a wonderful steel. 1000 Newton per mm square steel. GP, we call GP steel. And very common to see steels 500 Newton per mm square, strength and above. Next is aluminum, aluminum alloys. Good, equally strong, if not as strong as steel. For lightweighting, it is very useful. Then good old composites. In fact, my PhD was on composites. Back into prominence. CFRP particularly. My days, carbon fiber composites were very, very rare. Only aerospace industries were using it. Today, carbon fiber composites are available. Automotive industries have started using it extensively. But there is a comparison. Carbon fiber composite, you can reach or you can save weight up to 60%. It's huge saving, but the problem is that cost is about 10 times more. I have given a comparative chart and all. The handout is uploaded somewhere. You can make use of it. All the details, data and all are there. Another challenge, high strength steel, whatever I said, 500 Newton per mm square or 1000 Newton per mm square steel, forming is very difficult. We call an effect known as spring back. It will not retain its shape when you form it, when you stamp it, form it, and it will try to spring back will be a problem. Aluminum extraction production is costlier. CFRP, greatest material, no doubt about that one. You can lift a certain apparently heavy shape, you can just lift it. Problem is disposal, how to recycle it. You can melt aluminum or steel. What to do with CFRP? Still a big challenge. And we are all so used to spot welding. If you go to any industry, Tata Motors, Mahindra and all, you find automated robotic lines, miles of lines and all. People will not be there and all. But if you use materials like composites, aluminum or combination of aluminum, composite and steel, how to weld it? So gluing technique has come into picture. There are some statistics given. In 2030, almost 50% of the automotive joints are going to be, 40 to 50% of joints are going to be glued. Glue means adhesive joints. No more spot welds, because spot welds are not going to be possible. Huge technology shift. The knowledge available in that area is very, very minimal. How to study it, how to perform a simulation like FEA, what our people do it. Very difficult for glued connection or adhesive connection. Next topic is manufacturing. Conference theme. For me again it is digital, virtual. We work in virtual world, digital manufacturing. Why digital manufacturing is important? You can see, those who cannot read, entire product development time for automotive, Toyota has proved that in 36 months you can come out with a car from scratch, zero to final launch. then imagine what kind of, out of 36 months, about 24 months would be spent on the development. People like us, we work on the product development. Then manufacturing has to be done very, very fast. How to do it? Do everything in digital environment. I skipped this slide. Whether it is a press shop, welding, spraying means painting, assembly, engine line, supplier interactions, scheduling, advanced planning, all are made digital today. Even before the plant is set up, you can do it in front of your computer and get the necessary confidence that once the plant is set up, you feed everything and line will start functioning and vehicle will come out. You can be very, very confident. So digital factories. And this kind of 100% digital manufacturing has saved, like increase in manufacturability about 20%. I have given some statistics. Like product quality improvement about say 15 to 20%. Like a lot of statistics I have given. The last topic is, I have included this topic, reduced product development time. Why product development time has to be reduced? If you don't launch a product in time, you lose the opportunity of introducing. Why there are 40 odd manufacturers of EV two-wheelers in India? Suddenly, mushrooming. Every city has got a two-wheeler EV manufacturer. Why? They want to make hay while sun shines. Otherwise, it will be opportunity lost. How to do it? CAE. CAE technique is there for almost 30 odd years. I mentioned, no, I started using it in 89. Today in automotive world, from 24 months product development time, people expect us to support them or get the product developed in 12 months time. Huge pressure. So now like digital manufacturing, product development has become fully digital, and we try to do it in 12 to 15, if not exactly 12 months, but somewhere between 12 to 15 months, we are able to do it, support automotive companies to complete their product development. But it's huge pressure. What are the CAE things in automotive? Not only in automotive, it could be Caterpillar kind of heavy engineering, machinery, or pump industry, compressor industry, more or less the same. FEA, crash, safety, durability, NVH, CFD for thermal calculations, battery cooling. Battery today has become a big issue. Everybody is speaking about battery, fire and all. HVAC, air conditioning, CFD is used. Multi-body dynamics for vehicle dynamics. 1D system simulation. MATLAB. I have mentioned another tool, but MATLAB is a wonderful tool and education institutes get it at a very, very cheap price, concessional price and all. I always expect students to learn MATLAB. It's a wonderful tool and it will help you to flourish your career very well. A lot of tools are available. I have given some names and all. You can literally go through it. JD sir always likes it. He always wants me to speak about this one. 5-star rating. Today you might have seen, today people are boldly telling that my car is 5-star rated. 5-star for what? Safety. Mahindra and Tata Motors, imagine, Indian manufacturers took lead in this, imparting safety and achieved the rating. Very unfortunately not the Hondas and Suzukis and Toyotas in India, but they are globally, they are great people. In India they have not spent time or money or energy on achieving rating, 5-star rating. We had the privilege of achieving 5-star rating during the product development time itself using CAE. Safety is a big aspect, and safety simulation or crash simulation for passenger safety, pedestrian safety and vehicle collapse, crush mechanism and all, and the child safety. You all know, seat belt, airbag and all those combinations, energy absorbing structure and all this and all. Virtually the confidence built, and when it is tested at ARA or any other testing agency, it's whatever you predicted, you tested in CAE environment, you achieve it. I mentioned about cars, 5-star cars in India, Mahindra XUV 300, Tata Nexon, Tata Altroz, 4-star, not bad. They might have missed 1 or 2 points here, there and all, so that's why they are 4 stars. Mahindra Morazzo, Maruti Brezza, only vehicle from Maruti family, India's largest manufacturer. Every second car is actually from Maruti in India. Brezza, Tata Tigor, they are all 4-star cars. Good amount of Indian cars which are on road are 0-star cars. Please be careful. You are budding engineers. Very soon you will become professionals and you will be planning to buy a car. Please ensure that you buy a car which is safe enough for you, your family, and others. Not only safety, crash and all, crash happens once in a while. Once upon vehicle is condemned and thrown out. Whereas vehicle has to survive for 2 lakh kilometers or 3 lakh kilometers or 10 years or 14 years or 15 years and all. So every sub-component of the car needs to survive the torturous life of roads like beautiful roads like main road, Bangalore road or Kacha road. Kacha road means, what do you call that one? Not so good roads or rural roads. CAE helps to do all this and all. So CAE helps you to reduce the actual test things. Faster development time, minimizing design faults, opportunities for multiple design options, optimization. If the design is already existing, you can do weight optimization or cost optimization and new material assessment. The last topic is academic collaboration. You might have gathered, I gave a lot of emphasis on lightweight materials. A lot of research is required in lightweight materials. Material joining techniques. The knowledge what we have is certainly not adequate. And a simple strength of materials laboratory is enough, more than enough to do a lot of testing and arriving at models for material joining techniques. Plastic fatigue, a dark area. We have not understood it much. We know steel fatigue reasonably well. Aluminum fatigue, okay. Road load data and the duty cycle generation, I just mentioned. A vehicle may not live longer if it is constantly on rural road, but the vehicle will live longer if it is on Chennai-Bangalore highway. So how to relate it and how to extract certain load conditions for analysis or test modeling and all. Thermal cooling, safe batteries, very important, because that has become a big concern today. One clue I can give you, all two-wheelers and a good amount of three-wheelers, they are air-cooled batteries because you cannot afford to have liquid cooling, whereas cars are reasonably safer because they are all liquid-cooled batteries. So thermal management, use CFD and predict and understand. Electro-thermomechanical, multiphysics, this area is known as multiphysics for battery motor and all. It's a huge area for the institutes to get into and do a lot of research and support. Startups get into it, not the established players who get into electric vehicle development. So with this, I conclude my short speech and thank you very much for the opportunity. My best wishes for the two-day event and enjoy. Thank you.
Thank you, sir, for a very informative session and talking us through the recent trends and challenges faced in the automotive field and market. And now, I call upon Ms. Jayashree of Third Year Mechanical Department to introduce the Chief Guest of the Day, Professor R. Jnanamurthy, to the audience.
A very warm good morning to one and all present here. I am profoundly delighted to take an opportunity to welcome and introduce our chief guest, Professor R. Jnanamurthy, IIT Madras, to the inauguration of the International Conference on Energy, Smart Structure and Manufacturing 2022. Professor R. Jnanamurthy completed Bachelor of Engineering at Bharatiyar University. He has completed Master of Science by Research in IIT Madras. He received his Doctor of Engineering degree from Nagoya University of Technology, Japan. He served at the Institute for Material Research, Tohoku University, Japan, as a regular employee before joining as faculty at IIT Madras in 1997. He has been a visiting scientist at Indira Gandhi Center for Atomic Research. Professor Jnanamurthy has published more than 250 original research publications in reputed international journals and conferences. He has guided 7 doctoral scholars and holds a patent on an innovative surface modification process for surface nanocrystallization and fatigue life improvement. He has successfully completed many sponsored research projects for the government organizations such as NRB, ISRO, DST, IGCAR, and offered consultancy services to the reputed industries in India and abroad. He has been Director, Registrar, Professor, and Chairman of the Academic Advisory Committee of IIIT-DM. He is on the International Advisory Board of Japanese Society of Mechanical Engineers and serves on a number of government, academic, and industry committees and advisory bodies associated with the development of new institutes, curriculum improvement, and new product development. He has also served as an expert member of engineering education for the Next Generation Global Engineers, Japan. He has been a guest of honor to the convocation of Nagaka University of Japan in 2015, Anna University in 2014, and other reputed universities. In 2013, he received Best Alumnus Award from the Coimbatore Institute of Technology. In 2006, he served as the chairman for a surface engineering session during Thermac held in Venok, Canada. In 2001, he received a career award for Young Teacher from AICTE. Professor Jnana Murthy served as the founder director of IIIT-DM Kanchipuram and established a state-of-art of green campus at the outskirts of Chennai, and is an architect of design-centric engineering and smart academic programs in India. He also served as a mentor director for IIIT-DM Kurnool AP and director in charge for the Central Institute for Classical Tamil, Chennai. We are very much honored to have him as a chief guest for today's event. We are very grateful to Professor Jnanamurthy for accepting our invitation and marking his presence here. Now I request Professor Jnanamurthy to enlighten the audience with his invaluable speech.
Sustainable PPT. Second.
Okay, thank you. Very good morning to every one of you. First of all, I thank the organizers for giving me an opportunity to meet you all in person. That's more important, okay? So when Professor Tanigay is a long-term friend of mine, okay, when he called me, first I asked whether it is an online meeting or a physical meeting, okay? So when he said it is a physical, then I immediately accepted. So the reason behind that, you know that, okay, we got fed up with talking to the machines, okay. So our last 2.5 years, we are giving a lot of lectures. I don't know how many of you are attending. That is in the case of the online mode, okay. We do our job, but we also know that the other side is not fully attentive, okay. Hardly 2-3 students listen to the class in the terms of hundreds, and okay, rest of you just switch on and go away and come all the way, do all the other things, okay. So we got fed up, okay, really, okay. So thank you, Professor, for giving me an opportunity to meet you all. Okay, it's my pleasure to give me this brief note, okay. I hope I have some 15 minutes left over, okay. So I'll try to complete it at the earliest. Before I go to this topic, okay, so I like to, I thought, okay, it will be dominantly by the senior people, but I come to know that it is mostly dominantly by the undergraduate students, okay. It's a good opportunity, okay. Most of you are going to have a wonderful career in the next few decades. One thing what I like to mention to you all is that you need to keep changing your expertise in a very frequent duration, okay. If you think that, okay, you know everything, that means you can survive in this world only for 2-3 years. Things are changing a lot, okay. For example, when I joined back IIT after roaming around the world, okay, I started with fatigue and fractures by area of research. I was in an industry. I felt bored, okay. I should not name the industry, it's one of the top industry in Pune only. It's a good package, I liked it, okay, it's a good facilities and other thing. The thing is, you have to do the same job for, as a routine, okay, which was not fitting to me, okay. I just wanted to do something different in a shorter period, okay. So that forced me to go into an research line, okay, where we have a lot of freedom and do something different. If I am in an industry, then I have to do what the boss tells me, and I don't have freedom to do whatever I like it, okay. That is what is the limitation which forced me to go out of industry in the early days, okay. Then I did all my studies and I worked outside and then returned back, okay. So it was introduced nicely by our friend, okay. I joined this IIT Madras, okay. The area I got trained is a fatigue and fracture mechanics, the same close to our Professor Tanigaya Rasu at that time, okay. That's why I was examiner for a lot of students at that time and we became close friends. But I found difficult to continue in India because don't have the facilities, the one what you have, because the place where I work, as introduced by the introduction, it has a wonderful facility. It was the best in the world, I can say. Okay, if you see the ratings, it was a top research institute in the world. I enjoyed. Okay, so I don't have those kind of facilities. Then I had to move to some other area. Okay, so I liked it. I moved to another area. I continued in the applications of biomechanics and other things later. Okay. The difficulty is at that time, about 15 years before, because last 15 years I'm not doing any, 2017 onwards I'm back to the research, but before that I was in an administration, okay, and 10 years before that, okay. It was more on biomechanics and biomaterials and other thing I introduced in my area, okay. But unfortunately, in the mechanical engineering, students don't like to take these biological topics and other things. Job opportunities are relatively less, okay. So not able to get the research students in that domain, okay. Now the scenario is a little bit different. Okay, then I came back to the automotive sector. Okay, so working more towards on fatigue fracture and applied to the polymer sector. Okay, honestly, there are very few people who do research in the polymers from the mechanical engineering point of it. Okay, then that was my topic for about 5-6 years. Then I moved to the tribology, then surface engineering, then. The topic what I'm going to talk is something what I started in the last 2-3 years. Okay, after I completed my administrative things. Okay, there I introduced smart manufacturing. Okay, there's one other topic which is otherwise we call it as an industry 4.0. Okay, I think I want to be very happy to tell that okay, we are the first in the world. Okay, to introduce smart manufacturing as an undergraduate program. It's a blend of mechanical, electronics, and computer science and engineering. Okay. Initially, I was reluctant. Okay, there was a lot of no students will join if you put a new branch and other thing, but still we introduced. Then in the postgraduate level, it was introduced around I think 2010-11. Now imagine we are 22, about 10 years before we introduced. It's quite successful undergraduate program, as rightly pointed out by the principal. We need to go with an interdisciplinary. The smart manufacturing, what is the difference between the conventional manufacturing is a blend of electronics and computers with a mechanical mindset. Okay. So we introduce courses with 30% of these three associated streams. Okay. I want to use the word associated. There is no more circuit branch, non-circuit branch. All these are gone. Okay. Anticipating that smart manufacturing will be one of the topics which is needed. Okay. A student who gets educated in specific domains, like a core mechanical engineering taught by the mechanical teachers, okay, then it will be, you may find difficult to get into in a modern industry where the things are going to be much more advanced. Okay. So what I ask all of you is you need to get educated in a newer areas frequently. You need to keep changing your knowledge. Okay, so you should not think okay, I've done my 4 years project graduation. Okay, so this is sufficient, lifelong I can survive, it's gone. Okay, so things are changing so frequently. Okay, that too in the mechanical engineering domain, the things are changing in a very faster level. Okay, as nicely pointed out by Dr. Manivasagam. Okay, so it's we need to update ourselves. Okay, so if you think that okay, I am sufficient. Okay, whether whatever be the language or whatever be the software, you get expertise. Okay, I feel that if you don't upgrade to the next level in next 3-4 years, you are out of touch. So what I request is keep updating yourself. Okay, otherwise you will be outdated. Okay, so nobody will respect. Okay, that is what is going to happen. Okay, so even you will not, when you get married and going to be the parents, your kids, you will not be in a position to teach anything to them. Okay, so that much changes are happening. Maybe in the higher education, the changes are happening little bit slow, okay, because of so many reasons. But in the schools, the level of changes is quite drastic. Okay, you may find difficult to teach even the 6th standard kid. Okay, that's where we are moving faster and faster in a different domains. Okay, this is something I like to mention. Okay, so last 2-3 years I am just looking into this topic. Okay, I'll just get into some sort of an introduction to this area. Okay, it is something is from the internet, and then something is what we do it in the last 2-3 years. Okay, because I took this topic because this is a nice conference. I could see that different departments are getting associated. Okay, so if I talk more about manufacturing, I don't want to make it's boring for the other specializations. Okay, so I'm not sure whether how many civil engineers are here, and then mechatronics and other people are here. So I was just thinking, okay, some other topic which will be a little bit closer and it will be of very much important to you is something which I am going to discuss for just for 15 minutes or not more than that. Okay, so the topic what I selected for this group of audience is something engineering towards the sustainable development goals. Okay. Taking the mic after eminent speakers ahead of me, there is an advantage, there is a disadvantage. Okay. The advantage is they have given a brief introduction. Okay, so it will be easier for me. The disadvantage is something will be repetitive. Okay, now I cannot change any slides. Okay, just leave it to me. So something may get repeated, but I hope it will not be boring. Okay. So this is our campus. I think most of you would have come to the IIT Madras campus. We are in the middle of the metro. You know it very well. Okay. In the middle of the metro, we are in the middle of the forest. That is very, very important. Okay. So this is a route to Professor C.R. Muthukrishnan's lab. Okay, computer science in front of that. Okay. So you can just see this is, we try to maintain the ecosystem to the best possible levels. Okay. We are not allowed to cut any trees. Okay. Now we are also watched by outsiders also. We are taking care, although we are self-responsible towards that. Okay. We have about 12,000 students, and more the number of students we have the animals, monkeys and deers inside the campus. Okay. So we live together peacefully so far. Okay. And then we like to live in the same environment for many more decades. Okay. So this is a topic, and that's my email ID. If some of you is interested, then you can keep in touch with me in the areas of interest. Okay. What is this sustainable development? Okay. This is the key word which is going to dictate the governments of different countries for next 30 years or next 50 years. Okay. There are stringent guidelines given by United Nations that each government has to meet their own targets. Okay, which I will tell in the next few slides. So there is a force behind us. What is this sustainable development? We are happy with whatever we have. We like to take care of us. Okay, but are we thinking of the next generations? This is something questionable. The amount of garbage we generate will kill plenty of sea creatures. Okay, so we need to take care of it. We want to live comfortably, no doubt about that. We need to look towards that. But in the meantime, we need to take care of our own future generations, not only human beings, the entire world. This is otherwise is called as a sustainable development. This is a definition given by the United Nations. We just read it carefully. We have to meet the needs of the present generation, but at no cost we should not spoil the future generations. You want to have your own grandkids to live in a better atmosphere rather than better than ours. Is it possible? 15 years before, around 2015, United Nations formed a big committee. Actually, it is around 2010-12 to look into certain aspects that has to be taken care. Otherwise, the rate in which we grow, I think we will spoil everything in another 15-20 years kind of thing. So a lot of regulations are there. Governments are forced to do it. That we will look into this. See, this is something sustainable development goals given by United Nations. 17 goals. After 3 years of rigorous discussions with different people, different countries, representatives from different countries. They came at around 169 target goals to be achieved by 2030. Okay. That is why you can see a lot of heads of the countries are talking about all these things, because there is a lot of pressure on them to get into this kind of targets. See these things, okay, may not be readable from far off place, but you can just look into that sustainable development goal, it will come into this. It is not just only about technology, okay, it's many more things. If you feel that you get a lot of wealth and then you have everything in whatever you have it, okay, just imagine you have 5 Mercedes-Benz and all kind of things, okay. So if your society is not up to the level, you will not feel happy. What are you going to do that, okay? So that is what is meaning here. So no poverty, zero hunger. Okay. So we will be feeling much more happier if the whole country is on par, but you can see a lot of differences. Okay. By God's grace, we are all in a better conditions. Okay. There are millions and millions are below poverty. Okay. So this is goal number 2. No poverty, zero hunger, good health, quality education. If you look into the statistics, only about 10% in the world is getting a graduate degree. Okay? So you are one among the 10% like that. Maybe the number is much more less, I don't remember it actually. Okay? So what happened to the remaining 90%? They are not even able to get into a college. Okay? So quality education, gender equality. Okay? So in mechanical engineering, when we studied, okay, hardly there are no females. Okay? Even 10 years before, when I was taking our class, 1 in 100 maybe a female student in our mechanical. Okay. Now I see in my lab, I have nearly about 5-6 people who are doing research levels. Okay. It's a big change, I could see it. Okay. But still we have to go far. Okay. Like this, there are 17 targets given. I will not go into all those things, okay, because there are many things which is associated with engineering technology, which is we are close, and there are many things which are overall governance is required. Okay, so I will just give a brief about 4 areas where I am little bit associated. Okay, quality education, because I was head of the institute for about 10 years. Okay, and associated with this academia for a long time. And I am also now associated with the point number 9, industry, innovation, and infrastructure outside the country. Okay, so there is a sustainable development goal 9 was given to Japan for certain aspects. So I am associated in the education, which is mentioned in the 3rd box, which is an Gigaku. Okay, it is a science and technology education for the next generations to come. How to take it over there. So I just go annually and then give some lectures and make sure that it's getting updated over there. And then I am now doing research, getting back to the academia, so working on this architected materials for next generation. EVs is electric vehicles. A very nice introduction is given by my earlier Dr. Mani. And then we are also looking for high-speed railway. We are very much outdated. Although we feel that India is one of the big country, okay, we are talking a lot that we are in the top 10 or something like that. But when you go outside India, you will come to know that we have to go a long way to reach them. Okay. Even our first high-speed train is yet to come when the world is running kilometers and kilometers of that. Okay. We need to look into the better examples and look into that. Okay. So I was just traveling in the bullet trains about 30 years before, but we are yet to get on first bullet train out. Okay. So we are lagging about nearly 70-80 years compared to the advanced countries. Okay. So we need to go a long way. Then I am now recently getting into the sustainable materials. Okay, that is closely associated because of my involvement in this sector. Okay, so I'll just give a brief about these things. So just look into this global energy consumption, where we are going more towards that. See, coal going out gradually, but yesterday in newspaper we are going to buy tons and tons of coal. Okay, so we don't have an alternative, but we have to move out of this. Oil, natural gas, all 3 sectors are gradually, it is getting controlled by the world, not to go towards. The next 3 is something picking up because of this emission control requirements. Okay, so that is something. When you come to the Indian scenario, As you can see here, the coal, petroleum, and then the biomass is our sources for our energy. Okay. It creates all kind of nuisance to the environment. That is the biggest challenge. So all these non-conventional or advanced renewables based energy generation is very less than 1%. The government is pushing a lot, okay? They are forcing a lot of things to make it more solar and all those things. So, but still we have to go a long way. You can see this nice picture, okay? Of course it's downloaded picture only. I'm just bringing it to you. How much pollution we are creating in a power plant. The graph below, it shows the CO2 emission, okay? If you try to look into the first four, that is what is we generate about 80-90% of the energy today. The rest 20% of the energy is from the other sources, from the nuclear and other kind of things, okay, where our emissions are very much reduced, okay. So we are yet to go a long way to go towards an energy generation which will not harm our atmosphere, okay. So climate change and all those things you might have heard it, another thing. So this is the trend set by United Nations again. They have given a short-term 2030 trend and then 2050 what we should do it. But how far we will reach, we don't know. But at least the society is giving a target. If you don't do it, then things are going to be much more worse than what is going to be today. This is what is the speculation. One side I want a comfort, and another side I need to take care of my future generations. This is where the engineering has to go towards. Today's engineering, we want to look into our comfort, how to make the best car, but we are not bothered to see how much side effects we are creating to the next generation. The industries will be forced a lot. Now itself they are forced a lot. They are struggling. But still there will be much more stringent guidelines to meet this net zero emission by 2050. This is a target given by United Nations. There are a lot of arguments between the heads of United States and other advanced countries. They don't want to stick to that. Okay, because they don't want to sacrifice the comfort levels, but still there is an direction towards that. Okay. So I will not get into the details of this. Okay. So one is a green infrastructure. I learned a lot when I built a campus. Okay. That campus was given to me a free land, and the government of India was permitting me to build a campus. Okay. I learned a lot in that. Okay. So green infrastructure is something which we need to look into that. What is the green means? Try to generate as much energy as possible. Okay. Have enough solar panels, and then try to consume the energy at least for the daytime for an academic institution. So when it's going to an green rating, okay, there are ratings which are given by Government of India and also international platinum rating, gold rating buildings and other things, okay. So when you are going towards a gold rating building means then you should have a lot of points to get from different things. You should use sustainable materials, you should have a rainwater harvesting, you should have the window panels such a way that the energy is not getting lost, okay. One is you are cooling it, and the second thing is if it is getting lost through my windows, then what is the purpose, okay. So 30% will go away from that side. So these are all the aspects which are all need to be taken care in a green building. If you have a higher green building, then you will get a 5-point rating or something like that, okay. But still we need to go towards that. We use a lot of steel, we use a lot of plastics, okay. So a lot of energy is spent in making these things. So we want to minimize that, use natural materials which will go back into my recycling much more faster. The energy required to manufacture the material is less, and then also it will get back to the recycling is much more better. This is what is otherwise a green building concepts. So platinum, gold ratings and other things. So these are all something which are doing. Government buildings are asked to follow certain things. Okay, but in the private sector, still we need to go a long way to the. So designed with materials for sustainable future. The graph shows here amount of energy required to make the material. Okay, so indirectly it is a cost associated. So you buy something for some X rupees and another one is for 0.5X rupees means that much energy is spent in making it. So you can see at the bottom of the curve, the natural materials, the energy spent is very, very less. That is why we don't want to waste energy in fabrication, and then we want to go, in the meantime it is economical, it's environmental friendly. So this is what is the trend we are going towards. Okay. We have gone from steel, go to the metals, going towards the lightweighting things. Now the same lightweighting is achievable with the natural materials, provided a lot of engineering is done to make it comfortable for the requirements, whatever we want it, okay? So this is what something we try to do it. So now, energy efficiency in the buildings, let us take into that. Okay, it is applicable to the car, it's applicable to anywhere else, okay. So we do want to switch on an AC in the car, then in the meantime we want to spend minimum energy so that I am comfortable inside. So this kind of building, I think the principal will know the electricity bill, how much it is going to consume on that. Okay, a lot of energy is spent on that. Okay, so just try to look. This is the weather map for Delhi. See the situation over there. I think most of you would have gone to the Delhi. Okay, it is they are not like our Chennai. Okay, at least we don't need an cold clothing. Okay, but in Delhi the temperature goes from 10 degrees to around 40 degrees roughly. So in the summer they have to switch on the air conditioners. In the winter, they have to switch on the heaters because it is 10 degrees, not possible. So we need to have both happening in the Delhi itself. Forget about somewhere in the other places, okay? I'm talking about well-known places only. In Chennai, at least we need only cooling. We don't need, fortunately, by God's grace, we don't need any heating here, okay? Nature is heating us too much, okay? So this we need to provide. It means we need to have an insulation in my house. So if you spend a lot of money in an air conditioner, okay, you buy ABCD brand, okay, they say it's all energy efficient, but if your house is not having an enough insulation, okay, then it is a waste. Okay, so you need to, we are engineers, we can think a little bit better rather than just believing what is there on the one side and keeping the other side bad, okay. So insulation is something we need to go towards that. So now we use plenty of artificial materials over there. Can we move towards the natural materials? One is the entire building, another one is an insulation. I just took this topic because it is bridging between my civil engineering and mechanical engineering, so that will be a little bit easier. And we are also doing something on this, trying to see how best my natural materials can be used for thermal insulations. Okay? So because we are going more towards sustainability, coming away from my engineered materials, okay, which are required. We are generating garbage a lot. Okay? Just look into this table. How much plastic is there? But we cannot live without that. We are just going towards that. But what are we going to do? 80% or nearly 100% will be going outside to the garbage. And only 20% is getting recycled. The biggest problem is if we are able to recycle 100% plastics is wonderful materials. I do plastic, design with polymers as a course for last 10 years nearly, I think. Okay. So, but the biggest problem is we are not able to segregate the polymers. Okay. That is why we are not able to recycle it. So that is where an issue we have it. So now another concept is, we call this as an circular economy. You might have seen a lot of government reports telling that this is a circular economy. What is a circular economy? Economy is, you make something, use it, make sure that it's 100% is recycled. So you don't create waste like this. Okay. So this you can see it very frequently, okay? You just go along the roads, you can see one is man-made waste, another one is agricultural waste. Now we are looking into minimizing both. How to minimize this waste into your wealth, okay? So some of you may be from the villages, so just drive to the interior part of it. After this harvesting period, you can see piles of things getting, and what we do, just burn it. Whether it can be converted into high-tech components. This is something which is a part of my sustainable activity. Some activities we do it in our lab. I'm not getting into the details. So this is a famous Ashby's chart. I think some of you might have read it in your undergraduation. Okay, second year, third year. Okay, so natural materials. Plenty of the materials are available. How to use it? The biggest advantage here is they are all recyclable. That is the only biggest thing. How to make it to an engineering product is a challenge. Okay, this is something which the world is looking into this. So now coming to the greenhouse emissions, the last area, what I'm going to discuss is about the transportation sector, because I see a mechanical automobile departments also inside. Okay, yeah. See, this is a culprit. The emissions by road transport is significantly higher. 72% of the emissions is from the road transport. This is the data of European Union in 2016, okay?
And the rest of the things is very less. That too you see the cars. Now we are having a growing population. Cars are affordable. Okay, even if you get a job, okay, the first person who will meet you is a person who the sales department will come, and then he will tell, and he will give a car, and with a zero invest payment, and the rest he will collect it later. Okay, that much is produced and that much has to be consumed. So this is what is happening. 72% emission is from the road transport. How to control it? We are now getting into the topic what nicely introduced by Dr. Mani Vasakam. Okay, so this is the green mobility. So this is the topic which attracts a lot of my research students, okay, because they get a lot of things. Some of them are getting around 20K itself, 20 lakhs salaries, okay. So this is something very attractive. Just look into this. I am now looking into a green mobility sector, okay. I am not talking about our IC engines, okay. If somebody is from the IC engine department, pardon me, okay. So it is a big challenge in IIT Madras for us, okay, because still we have a department and they don't want to come out of it, okay, but still we are forcing us, they have to come out of it, okay. So engines are going to be out. So many times people think that, okay, going to an electric system is just take away the engine and put your thing and it will run, okay. It's not like that, it's not so easy, okay. So it's not so easy, okay. There's a lot of things inside, okay. I will not get into the details. So a lot of things inside. So it is not just take away the engine and the same place you put your this battery pack, it will run, kind of, no, it's not at all, okay. So just look into this bottom, okay. The electricity, the vehicle size is there on the y-axis, and the x-axis is the driving distance. The challenge faced by the electric cars, what is the challenge? Why we are reluctant to buy? Even I want to change my car, but I am a little bit reluctant. Unfortunately, I don't have an affordability that big person who was driving with a hydrogen car, okay. When a common man is going to buy an electric car here, the charge per kilometer per charge is the biggest challenge right now. I take my car to go to my native place, which is around 350 kilometers. So I have to go and then come back in the same day, means I cannot wait for 5 hours charging and then only I come. Who will buy a car? So this is the policy decisions. There are certain issues which I should not talk openly. Policy decision, we should go in a level. Right now we are in IC engine world. We have to go towards an hybrid mode. We have to go towards next to one fully electric mode. Then we go to an higher electric mode, okay. But right now the government is telling that we have to go to an electric mode directly. Where is the charge stations? Where is the infrastructure? I cannot go and then wait for 8 hours to charge and then come back. Okay, who will buy a car? Okay, this is a challenge what we have. But the rest of the world have gone in the stages. We missed certain stages. Similar to the smart manufacturing, okay, industry 4.0. 1.1, 2 we were up to date. 3 we missed it. Suddenly we are forcing to go to the 4. Okay, it's not possible. Without doing a graduation, if you cannot do a doctorate, then it's difficult. Okay, so you have to go in stages. That challenge is forcing a lot on the consumers, whether we can have a charging infrastructure enough, whether we have a battery sweeping technology or whatever be the thing, whether we have it or not. So we can limit it. Okay, I have a scooter, okay, I am fine with it. Okay, maximum 20 kilometers I go and come and then put it in my charge, and when I go into the car, then it's difficult. So electric vehicles is right now limited because of this major challenge we have it. Then we are going with an hybrid. Okay, we have IC engines together. This is what we should go, okay. Then mature it. By that time we are confident, consumer is confident, okay, my battery vehicle is safe, okay. Not everybody is an engineer, okay. So they have to understand, okay, electric vehicle is safe, so I can confidently take to Madurai and come back without any problem. That much confidence is there, then naturally people will buy. So that is something that will come if I have a plug-in, okay. So I drove these cars about 25 years before when I was outside India, but still in India we are yet to get it. So we are very much going back. I mean, there is a gap is large. We have to go towards that, okay. So it automatically changes. The driver will not know. He will simply drive. It changes to engines and it changes to the electric motor automatically. Depending, okay, if you are parking, then it goes to certain things, okay. It goes to the other weekend. So that technology has to come first. Then we have to go to a fully electric. The next one is a fuel cell, okay. That is something which is more advanced. We are little bit long way to go towards that. The driving distance, there is no charging there. There it is something like filling a hydrogen and going towards that. That is going to be something different. So this is a graph given by our Honda, okay. So what they are trying to do towards global warming requirements. They do a lot of research in engine technology so that it is better efficient and other things. The emissions are under control, are better and better. This is one trend, bottommost one. And then they go to the hybrid, then they go with a plug-in hybrid, then the topmost one is something you can see the brands also, Clarity, Fit, Clarity fuel cells. This is a fuel cell based, otherwise hydrogen cars. Okay, so zero emissions. So the chart shows what is the amount of CO2 emission associated with that. Okay, so this is the trend of the world. Okay, so you just look into that. I'm just looking into only the green mobility sector here. We have a battery car, electric vehicle. Okay, full of batteries at the bottom. The next one is hybrid, engine plus battery. Okay, charge the battery and then use it. Okay, so that at least the engine is there, I can fuel it and then run it without any difficulty. The next one is little bit a higher level of battery levels and then go towards a reduced this one. So all programmed. Okay, that is where your computer science come into the car. That's where your 7-8 lakhs of rupees, as pointed out with Mani Sangam, is there. Okay, it controls everything. Okay. But still mechanical engineering dominates, okay? So don't think that, okay, remaining 12 lakhs is mechanical engineering, okay? So next one is an FCEV, fuel cell electric car, okay? So that is something which is going to be running with an hydrogen, okay? Toyota is taking a lead in this sector, okay? There are a lot of things, okay? A lot of things happening in the world. Certain companies, which I will not mention it, thinking that it's going to be an electric vehicle battery charged future. Certain companies feel it's going to be an hydrogen things. Okay, so accordingly they give an importance. Okay, so but Toyota is something which is giving more importance to the fuel cells based cars, although there are issues. So what is happening in this fuel cell based car is you have a hydrogen station. Just fill the hydrogen. Okay, there is very small battery like what we have it in our existing IC engine car. The battery is only to start and stop kind of thing. Okay, so it is dominantly, hydrogen is a source. You have a fuel cell, and then it generates the power which is directly drives your electric motor, and then we are running it. This is what is the concept of the fuel cell. There are challenges. Challenges is what? Hydrogen management. Okay, so it is a little bit risky how to design a hydrogen tank and kind of things, but this is nearly, there is no battery there inside, or a minimum smallest battery compared to the battery vehicles. The biggest advantage here is recycling of the batteries. So you can't use a battery for 20 years, okay, you know that very well. Okay, so maybe 2 years or maybe 3 years, what are you going to do with the bulk of batteries outside? It's going to create an environmental pollution. Okay, so that aspect is not here. Of course, the technology has to come, mature it, and then we have to go towards. So what I do in some of my research is working on this fuel cell reliability. Okay, I'm a mechanical engineer basically, so I just look into this fuel cell reliability because it's going to be there with you. You are sitting on the fuel cell, it's below you, and then you are driving it, and then it is handling hydrogen, it's risky. So how it's going to survive? So different advancements are there. What we are looking into that, going much more deeper, is working on that, mainly this graphite GDL plates, which is used. We are now looking into how to use lightweight nickel-based foams or aluminum-based foam or steel-based foams to make it a better energy efficient. This is some of the activities done in our lab. Okay, so our intention is to see the reliability of the vehicles. Run it, just see what is happening, because it is dominantly by the chemical people. So fuel cell research is dominant by the chemistry people, trying to find out which is the best system, which is more energy efficient, and now we are looking into the reliability. Okay, how best, what I can do it. Okay, so another sector is the drive motor. Whether you are going to use an battery vehicle, BEV, or you are going to use any source, whether it is a solar panel, anything, finally what is there is an electric motor. Okay, so what is the difference between the type of electric motor used there and the one which is used in my cars? How this electrical environment is going to play a role? Okay, I'm just skipping some of the slides. Okay, how this electrical environment is. This is something close to what our Dr. Manivasagam has mentioned. The electro-mechano tribological aspects, thermal aspects are going to play a role. Reliability of the bearings under the electrical loads. Okay, so this is very important because in a car you want to have a perfect silence. Okay, so that is something which we need to look into that. So we are just trying to look into how this electrical environment is going to affect my bearing performance. You know very well the bearing design. What you have done? You have taken the static load, dynamic load and calculated with different conversion parameters and found out what is the life of the bearings. Okay, this is what you have done. Have you ever bothered to see what is the electrical load is happening? What is going to happen when a current flows in the bearing? The lubricant is going to evaporate. So a lot of research is done on that, and then we are also doing something on this domain. Okay, so different kind of failures, how it's happening, how to minimize it, how to make a lubricant which is going to be more performing in these environments is something what we are doing. So I just summarized 3 different domains where I am little bit associated. This is my first talk, so on this topic, okay, so because we are recently started on this domain, trying to look towards the sustainability, trying to link it to our own expertise where we can contribute on this. Okay, so any doubts you can email me, or if someone is interested in doing so higher level research, and of course you are always welcome to this one. Once again, I thank the organizers for giving me an opportunity to do this. Thank you.
Thank you, sir, for sharing your immense knowledge on sustainable development and goals. Request? Request Dr. C.R. Muthukrishnan, the advisor, to present the memento to the guest of honor, Dr. Mani S. Manivasagam. Request Dr. S.N. Murugesan, the principal, to present the memento to the chief guest, Professor R. Jnanamurthy. Requesting Dr. G. Thanigayarasu, the Dean of Mechanical Sciences, to present the memento to the advisor, Dr. C.R. Muthukrishnan. Now, we would like to play the teaser of International Conference on Energy, Smart Structure and Manufacturing 2022. Off the lights. Thank you. Requesting the participants to kindly refer the file provided to know more about the venues for the paper presentations. And the venues would be Purple Hall, Seminar Hall, Mini Seminar Hall and Heritage Hall. Now, the students and faculties are requested to gather near the entrance for of the workshop block for the group photo, and kindly join us for the refreshments provided outside the seminar hall. Thank you.